Okay, so let's try y double prime plus 4y prime plus 4y is 0,
That'd just be minus 2.
which is a
Second order.
twalkaload. Yep. How do you spell twalkaload again? Second order linear constant coefficient
Ordinary differential.
homogeneous ODE. Twalkaload?
Actually, that smells like twackle chip.
Yeah, so it was second order
There we go.
linear constant.
2olcchode.
It was constant yeah, whatever.
Yeah,
I don't remember. Anyway, how do you solve these?
You take a guess
You guess?
that y is equal to e to the r.
Maybe t?
Hey, I was close.
And really some constant times this, right?
Distribute that through.
Okay, so you put that in here, you get r squared e to the rt plus 4r e to the rt plus 4 e to the rt is 0. Then what?
Divided by e to the rt.
Cool.
Back that out.
Multiply through by 1 over e to the rt. Get r squared plus 4r plus 4 is 0.
Factors to 2 is x plus 2.
Yeah, good. Factors to r plus 2 quantity squared is 0.
So negative.
So you get r is -2 and -2.
Correct.
And then you're like, okay, so then the solution is y is a e to the -2t plus b e to the -2t, right?
Yeah.
Okay, so the problem is that that's not actually two solutions. There aren't actually two arbitrary constants there.
Just factor them out.
There's really just one,
Right. It's the same thing.
right? Because they're e to the -2t and e to the -2t, so you really should combine those. So when I'm trying to solve these, there's going to be a couple initial conditions, right? So if my initial conditions were something like y of 0 is 2 and y prime at 0 is 3, then I'm going to use up all of my arbitrary constants with one of those. You guys see that? So somehow this problem got away from me, and there's a little bit of a thing here. What's going on is that these two solutions, big kind of two solutions, aren't linearly independent because they're actually identical functions. Right? And linear independence gets a little more complicated when there's 3 or so. But in this case, they're pretty clearly not linearly independent, and so you need some way to get the second one. And the cool thing is, if you have, in the case that you have a repeated real root, right, which is the only case that we're going to be concerned in the twalkaload case, right, you can get a second linearly independent solution by adding a t to the second factor.
Slapping one on.
Yeah, so in order to demonstrate that this is actually working, I really have to check that one. So I'm going to spend just a second and check that just to show you that it works.
Did somebody just say, hey, we need a T here? Or was it like an actual mathematical?
Yeah, it's actually a little bit like, well, that didn't work.
Let's try it.
What could I throw on there to make it work? And the most obvious thing is a t. And the reason you might think a t is a good choice here is when you differentiate this thing. So let me take part of my solution, y is b t e to the -2t. So I should calculate y hat prime. What's y hat prime here?
B T.
bt e to the -2t plus
Nothing. -2.
oh wait, what do we screw up there?
-2.
Oh, yeah.
Yeah, it'd be -2b. -2b
No,
t e to the -2t.
You can't absorb the.
You should do it.
No, because it's a b here.
So it's like b prime.
Yeah. What do you get here?
The other,
The other thing?
t, e, -2, e to the -2t.
No, I did that one.
No.
Oh.
Product rule, right? So I differentiated
It's too many letters.
the e to the minus 2t part here.
Yeah, so you got like B, T, or B.
So you get b e to the minus 2t.
B, e, t, t, 2.
And then you do it again because you need the second derivative.
Oh, that's a shame.
It's kind of a shame. The good news is you did this first part, right?
B, t.
So just write this thing down in parentheses.
Yeah.
That's dumb.
Right? Because I already differentiated that thing.
Minus 2b.
And then you get a minus 2b e to the minus 2t.
Let's see.
Okay. And then you take that over here to your differential equation, plug it in, and see, right? Like my plan's going to be to see if it works. So I have, oops, not negative, but positive 4 bt e to the minus 2t
Minus 2b.
minus 2b e to the minus 2t.
Minus 4b. You can really just say
Yeah, you can
minus
just
4b.
slap them.
Wait.
You can combine like terms.
So I got first thing, second thing.
And you subtract.
Oh, and you're saying that this is the same thing as the other
Right.
one. Okay, cool, good. And then from your y prime, right, you get plus 4 times a minus 2bt e to the minus 2t plus b e to the minus 2t. And then from your y, you get a plus bt e to the minus 2t. And then this whole thing's supposed to equal 0, right?
Plus 4 times y.
Oh, plus 4 times y. Thank you.
Oh man.
So I have here y double prime, right?
Yeah.
First row. Second row is 4 y primes, and third row is 4y. And the reason I did this is that I want to show what cancels and the way it cancels. So this guy canceled against that guy. You see that?
Wait, why are those 4s up front, real quick?
Just 'cause I didn't want
So these two 4s are from distributing
Yeah,
that
got
stuff.
that, but then the.
And this one is that.
Oh, crap, okay, yeah.
And this one is that.
Okay, gotcha.
Okay, so I got these two guys, those cancel. And then I have
Half of.
8
to.
Yeah. Oh, so
bt
that's
e to the minus 2t, and minus 8 of them here. And the miracle of that was that these two things canceled on their own. Right? And the reason that those two canceled on their own was that the e to the minus 2t was already one of the solutions. You guys see that? This trick won't work if you only have, so if you only have one root, like if your characteristic equation factors into r plus 2 and r minus 2, then t e to the minus 2t won't be a solution. It just won't work. Because the thing it needs to work is that minus 2 is already one of the solutions and that it's also the second. You guys see that? So this tossing a t trick on only works if it's repeated. You guys good with that? So I think now you have all three cases. In the case that there's two different roots, you just slap them both in the exponent of a t, slap some arbitrary constants on it, and move on with your life. If they're complex, you have to use Euler's, right? And if they're the same and real, you just do this trick where you slap a T on the second one.
And call it a day.
And call it a day.
And then you should get, do you have to show that?
No, you don't have to go through this every time. You guys can just assume that if you get repeated roots, you can slap that T on it. You guys good with us? Okay.